So to remind what we set out to do, our agronomic agenda is has four sort of levels in there. One is that we want to address the soil health by managing the soil organic carbon, biodiversity, etc. Then we want to improve the nutrient use efficiency of the macro and micronutrients with high productivity. The third layer is that we want to minimize the environmental footprint at the farm level. This also goes to the greenhouse gas emissions to reduce them. And then the fourth is to address or to improve the stress tolerance and recovery of plants as they are exposed to different stress factors because of the climate change. This is sort of our soil health agenda, and it involves really reducing the greenhouse gas emissions, improving the nutrition, and optimizing the different levels of the inputs, both the synthetic fertilizers and the organic input that goes in there, and the more, let's say, advanced ways of introducing carbon and biology into the soil and soil amendment. And these are some of the examples of solutions. And I would highlight in specific the soil health, biologicals, and carbon because they are actually addressed by the solution that we selected. So stop sharing. Okay, so we had a team on our side of 4 people. It was Adi Perlman, the agronomist that is also on the call, the R&D agronomist, Hadar Zadovsky, who's the VP of Corporate Investments, and Yara Shimoni, who's also here on the call. And in the back end, you could say, we consulted with many other stakeholders in ICL. We ended up by converging to 3 companies that we evaluated. 2 of them were more on the analytical side, so kind of looking at what's there, seeing what stress is in the soil and what is the level of the different nutrients in the plants in an innovative way. So this was the analytical side, and one company was more on the material side and the input and changing the input. And after many conversations with the 3 startups and getting the POC proposals, we realized that our way, ICL's way to impact regenerative agriculture is through the inputs, is through the materials. And although analytics are aiding this to understand what's needed, in the end, the impact comes from the materials that are introduced, the way that they're introduced into the soil, and how they improve the soil health and all the other parameters that I showed before. Um, and we decided to go with Kiana, also because we really appreciated Sanem's explanations, patience, and professionality. But then we're going to a POC, not because we believe that all the claims actually work the first time that we're going to use them. We are taking an approach that we don't know. We have some concerns. One of them is about the bias that lime introduces into the composting process that Kiana offers. But this is exactly what a POC is for. And we're going to test those different assumptions and claims during the POC. And we are very much looking forward to it. And if indeed the claims prove correct, and one of the main claims is that this treatment can reduce the composting process by 50%, if not more, depending on the conditions, then this is a real breakthrough, and we believe that we can really work together much beyond the proof of concept. And I would say that we did not abandon completely the other two companies, and we are thinking to test the methods because we believe that they are innovative, especially the one that could that can measure nutrients in the plant using an enzymatic based sensor. So, so we're looking forward to the next steps, and especially to the results of the POC with Kiana Agriculture.
Sure. Thank you very much, Ziv. We were very happy to work with you as well, with you and also with the ICL team. I will very briefly first share my screen and then okay, can everybody see?
Yes.
Okay, great. Okay. We are very happy to be here this evening, and thank you again to the whole ICL team. We had a very fruitful process in this challenge. At Kiana Agriculture, we develop biological solutions to some of the major problems in agriculture today. The problems we focus are soil degradation, water and soil pollution. The problems come with the change in the ecology due to climate crisis, such as temperature abnormalities and emerging diseases. And in the overall, one of our major goals is to reduce greenhouse gas emissions resulting from agricultural practices. And this will be also the goal of our POC with ICL. In our products, we use enzyme technology and our proprietary microorganisms together with several different biocompounds. So ICL's polysulfate is a natural fertilizer that provides potassium, sulfur, magnesium, calcium to the plant. It's a sustainable, environmentally friendly and low carbon footprint product. When it is applied to the soil, it is applied with an external nitrogen source. And this external nitrogen source mostly comes from manure compost in countries like the Netherlands. Manure compost is an organic fertilizer, but not very much climate friendly. The reason is that the conventional composting process is very long. And because of this lengthy process, greenhouse gases such as nitrous oxide, ammonia and methane emits to the atmosphere. So our primary goal with this POC is to decrease the composting time and in return decrease greenhouse gas emissions. And secondarily, conventional composting process is inefficient because of insufficient mineralization. Manure has a good amount of proteins and amino acids in its composition, but due to lack of enzymes and microorganisms, nitrogen conversion from these organic compounds is low. So secondary objective would be increasing the mineralization to increase the nitrogen use efficiency. So for this, we will use our product called Compost Fast, which is composed of enzymes, microorganisms, humic substances, and natural minerals. The activity of enzymes and microorganisms in the product decrease the time required to convert manure into a stable compost, which means that there will be less greenhouse gas emissions. And also it increases the final N content of the compost by mineralizing more organic N from proteins and amino acids into the nitrogen that plant can actually uptake. So it will be higher nitrogen use efficiency. The humic substances in the product, especially the functional groups, prevent leaching, and the natural minerals help maintain the required pH value. So the location of the POC will be the Netherlands, and our success criteria is production of a stable compost at the time, at least half of the current composting time. So for this, we will apply our product in a ratio of 2 to 3 kilograms per 1 ton manure, and we will constantly irrigate and mix to keep the moisture at a certain level and a pH higher than 5. And at the end of the trial, we would like to measure some quality and stability parameters like pH, EC, pathogen content, heavy metal content, organic carbon, organic matter, nitrogen, and carbon to nitrogen ratio, and also for the stability, specific oxygen consumption rate, and also we would like to do a DEVAR test. So overall, this is our POC, and we are very excited about it, look forward to it. But before concluding, I also would like to thank Marie and Roman, because we were also in BayWa TUM-Track, and we are also very happy that we will keep collaborating with them after the challenge. So in overall, I would like to thank the organizers for this excellent challenge. We could come up with several good ideas with 2 companies. Thank you very much.